Okay, so this lesson today is on multiplying and dividing rational expressions. And I just want you to kind of go over something that you probably did back in 5th grade. You may or may not have broken it down in this manner, but let's start with 2 over 7 times 21 over 40. So most of you guys, what you're going to do is you're just going to pick up your calculator and you're just going to type it in, which is totally reasonable, but we can't do that when we do polynomials. So what we're going to do is we're going to review how you would normally do this without a calculator, because it is exactly the same way that you would do it, with polynomials, okay? So what you do is you think, is there anything in the numerator that I could possibly reduce with anything in the denominator? So right now you've got 2 and 21, and then I've got 7 and 40, top and bottom. So what I did is I used prime factorization. So this is typically how you would break down numbers in your monomials, okay? So you would just use a factor tree or whatever method that you use for your prime factorization to break it down. And then what you do is you look for things that you have in common in the numerator and the denominator. So I've already got it crossed out here. So this 2 right here would cancel with any of these 2's. It doesn't matter which one, I just picked this one. And then this 7 would cancel out this 7. Now I want to make it very clear, just because I've been asked in the past, do they have to be in the top and the bottom? Absolutely. You cannot cancel out these right here because 2 times 2 is 4. The only reason why we're able to cancel out those 2 7s is because it's division. So 7 divided by 7 is 1. So that's what we're doing. We're basically just reducing and eliminating common factors. And then all you've got to do, once you eliminate all your common factors, you multiply across the top, multiply across the bottom, and you're done. And if you actually did the first steps right, then you don't have to worry about simplifying at the very end. Okay? All right, so let's look at some helpful hints for multiplying rational expressions. You are definitely going to want to factor everything, numerators and denominators. So when you are adding and subtracting, you don't factor the top, you only factor the bottom, so you could easily find a common denominator. Okay. You also want to check for undefined values, whether or not you're asked about them or not. Always look. Then you're going to find common factors that you can eliminate, and then just leave your answer in factored form. Okay. The only time you would ever not leave your answer in factored form is if you were doing like an ACT prep or doing a TN Ready and it's multiple choice and they are multiplied out. Okay. But if you're using something like Delta Math, you can absolutely leave it in factored form. All right, let's look at this example here. So the first thing you want to do is look and see if you can factor any of this stuff. I do want to point out that 3x squared is a monomial, and you have to treat monomials differently than binomials and trinomials. So 3x squared in your brain, you need to realize that you can actually separate the number and the variables. Now, in this particular example, it's not an issue, but it will come up later. So I'm just saying, as future reference later on, you may need to do that, okay? Now, this trinomial here has a GCF of 2. Then you would continue to use trial and error to factor it here. And then this one is just simply trial and error here. And then once again, trial and error here. So it can be any of them. It can be grouping, it can be trial and error, difference of squares, it could be slide and divide. GCF is also very common. So you just have to be really, really good at factoring. Okay, so now what you do is you look at monomial factors. So my monomial factors, I have a 3, an x, and a 2. Notice they are all in the numerator. I can't do anything about any of those because I can't cancel anything out unless it has a common factor in the top and the bottom. Okay, so that's kind of out. Now, let me erase this temporarily for a second. You see how I've got the x minus 5 here? X minus 5 is a binomial, so if you want to reduce that x minus 5, it has to match exactly to another binomial, which is x minus 5. So those are going to cancel out. Yes, it can be part of the same fraction. No, it doesn't have to be part of the same fraction, but it has to be numerator and denominator. Absolutely has to be that. So this x plus 2 can cancel with this x plus 2. Now there's something that I didn't do that I completely skipped over, which is right here. We're going to check for your undefined values. So before you start having fun, because that's the fun part of this, in my opinion, just to start marking stuff out, look at your denominator. So remember, your denominator is not allowed to be 0. So any of the factors in your denominators, I don't care how many denominators you have, none of those factors can be equivalent to 0. So this first one right here, this x minus 4, if you plugged in a positive 4 there, that would be bad. So your first excluded value would be positive 4. So this one right here, x plus 2, x can't be negative 2. So I'm just kind of notating it here. And then x minus 5, x cannot be a positive 5. Then you got another x plus 2. That's going to create another negative 2, but you already have it listed, so you don't have to list it again. So these are just things that might possibly make it undefined, just in case you're asked about it later. So after you do all that fun stuff and you mark everything out, then you just kind of write down what you have left over. You do need to simplify the monomial. Okay? You do need to simplify that. So you're going to multiply all of those across. You're going to get 6x squared, but you can leave the binomials or trinomials alone. You do not have to multiply those out. Okay? All right, let's go ahead and just do number 1. So what you want to do is you want to look at each part of the fraction and see if we can actually factor any of it. So I'm going to focus right now on this yellow section. So I've got x squared minus 8x. Number 1, we always look for GCF, right? Y'all see a GCF in that? X. Okay, so ideally we can just do greatest common factor in our head. So if I take out a GCF, that leaves me with x minus 8. And I'm just going to completely rewrite this. Okay, now I'm going to focus on this green section right here. It's partially factored, which is great. I'm going to still, it looks like they had a GCF of 14. That's what it looks like. But I'm probably going to need to factor out the x squared plus 8x plus 15. Since that's a trinomial, what we can do is set it up using the x. It's not going to be a slide and divide, so because of that 1 in front of the x squared here. So I need to find factors of 15 that add up to be positive 8. And that looks like a positive 3 and a positive 5. So it'll be x plus 3 and x plus 5. Okay, moving on to this section right here. Looks like I've got a greatest common factor of 7. So it leaves me with x plus 5. And this part right here looks like I can't do anything about it. It doesn't have a GCF, it's not a trinomial, and it's just linear. So I'm just going to leave that x plus 8. There's nothing I could do. But it is a binomial. Now, before I start doing that fun part of just marking everything out, you need to look at the denominator. So look over here. Remember, x's create excluded values. Only the x's. So that 14 is safe. That doesn't create anything excluded. 14's 14. 14's not going to just turn into 0 for no reason, okay? But what about this x? That x cannot be what? Good. Cannot be negative 3. Okay. This x cannot be negative 5. And this x cannot be negative 8. Okay, so just kind of off to the side, I notated anything that would create an undefined expression. Okay, now what I need to do is look at my monomials. So I'm going to highlight my monomials in yellow. Okay, so I've got an x, and then I've got a 7 in the numerator, and then I've got a 14 in the denominator. That x I can't do anything about, but what about the 7 and the 14? What does that reduce to? Because y'all know that 14 is 2 times 7, correct? So that 7 and that 7 will reduce, but it will leave a 2 factor. So I'm going to put x and a 2. So that's monomials first. What about binomials? Y'all see any binomials that we have in common? What about this x plus 5 and this x plus 5 right here? So as long as they are exactly the same sign, same everything, they're gone. And I don't have anything. Now I want to cancel out the x, but I can't because one is subtraction, the other one's addition. So I'm going to just write final answer x minus 8. And then x plus 3. And then x plus 8. That's it. Okay, so let's take a look at number 2. Now, number 2's got several monomials in there. So when I factor, I'm just going to break them down a little bit. So I know that 4 is 2 times 2, and then I know x squared is just x times x, okay? You do not have to do that. If it helps you, go for it, okay? Now, the second one right here, the 2x minus 10. Looks like I've got a GCF of 2. And that leaves me x minus 5. Okay, so this x minus 5 here, there's nothing I can do to factor it. There's no GCF, nothing else. And this monomial x to the third, you can write that as x times x times x. So like I said before, you don't have to do that. It's just if you're really visual, it does help. Okay, so let's look at monomials first. So all of these are monomials right here. And the other two are binomials, okay? So I can go ahead. Oh, wait, what did I forget to do? I got to look for what? I got to look for excluded values. I got to look for excluded values. So what is going to create an undefined value? This x is going to create an undefined value. So that x cannot be positive 5. And what about all of these individual x's? They don't have anything added or subtracted to them, so they can't be what? They can't be 0, right? Okay. So this 2 right here, divided by that 2, they will go away. And then I have an x here. Looks like I'm not marking them out. Looks like I'm putting another x, but these are going away. Okay, what about my binomials? Are these the same? Yes. So I'm going to go ahead and mark those out. So what did I not mark out? So I have a 2 and a little x right there. So that whole thing actually reduced just to 2 over x. So it's kind of cool that you only have just that part left over. All right, let's take a look at number 3, and I'm definitely going to want to rewrite this one over here. So the x squared minus 9, that is a difference of squares. So x squared minus 9 is going to be x plus 3 and x minus 3. Okay, it looks like this one right here, we need to factor using that x method. So factors of negative 24, that add up to be negative 5. Let's see, negative 24, that add up to be negative 5. What do you guys think? 3 and 8? 3 and 8. Looks like positive 3, so plus 3 and minus 8. Okay, top part over here, can't do anything about x minus 8. I'm just going to leave it. And then I have a GCF over here. I believe that would be 2x. So I would have an x minus 2 left over. No, that would be 9. Okay. All right, so now that I've got it all factored out, let's just take a second and look for anything that could be undefined. And remember, your undefined is from x, from unknown values. So this x cannot be negative 3. This x cannot be positive 8. Okay, this is a GCF x. Remember, it's not added or subtracted, so that x cannot be 0. And this x cannot be 9. Okay, for the fun part. Looks like I only have that one monomial, that 2, that x. I can't do anything, so I'm just going to leave that 2x. Now, what can I cancel out binomial-wise? Got an x plus 3 and an x plus 3 here. What else do you see? Okay, x minus 8, x minus 8. And that looks like that's all we've got. So I have an x minus 3. You don't have to keep it in parentheses because there's nothing else around it. And then I'm just going to rewrite 2x and then x minus 9. Final answer. Okay, so on number 4, go ahead and we're going to pause the video, and I want you to try to factor as much as you can on your own. There's really not much. And then let's see what happens. Okay, so it looks like we only have one little section that needs to be factored, and this section has a greatest common factor of 3. Okay, so now what I need to do is write down my excluded values. So this x cannot be positive 9, and this x cannot be negative 1. Okay, so if I want to start eliminating things, my monomials are here. They are both in the numerator. I can't do anything about the x. I can't do anything about the 3, but do y'all see any binomials that I can get rid of? X minus 9. So this one can be marked out with this one. And that's the only thing I could possibly reduce. So I'm going to write my monomial as simplified and then leave everything else as factored. And there we go. That's it.